Hello class and welcome to our today's lesson. In our today's lesson, I want us to continue from where we left as far as correlation is concerned. Yesterday, as I was introducing this particular topic on correlation, I said correlation is actually a measure of interrelationship between variables. And in this case, when we are talking about variables, there are actually two items. If, for example, I want to measure the relationship between something like price and quantity demanded. These two, they are my variables, the two, whereby the price change is used to determine the change in quantity. These two variables, they are known as either dependent or independent. One variable is known as dependent and the other one is known as independent variable. The independent variable will be used to measure change in the dependent variable. Like for example, in this case, what will affect the other is actually the price here. The price level will determine the quantity that is being demanded. So in that case, the price will be regarded as our independent variable and the quantity demanded will be our dependent variable, because the quantity that the consumers are going to demand will depend on the price that will be charged. And as we know from economics, the law of demand, as the price goes up, the quantity demanded goes down. So you will find now the quantity that is going to be demanded is our dependent variable. The dependent variable is normally denoted by Y. The dependent variable is normally denoted by Y, whereas the independent variable is normally denoted by X. So whenever we are measuring correlation, or whenever we want to measure the interrelationship between variables, then we need to have the two variables in place, the dependent and the independent. The dependent will be denoted by Y. Always you will be given the figures for Y and the figures for X. So we want to know the effect of X on Y, or the effect of the independent variable on the dependent variable. Having said that, allow me to talk about the nature of correlation. Let us talk about the nature of correlation. Correlation can either be positive or it can be negative. So anytime you are measuring correlation, you can either have a positive correlation or a negative correlation. Let me start with the positive correlation. Let me start with the positive correlation here. The positive correlation will mean the two variables that you are studying. The two variables that you are studying. Remember, we talked about the independent variable, which is actually our X, and we have talked about the dependent variable, which is our Y. When it is a positive correlation, you will find that whenever X is increased, Y will also increase. Remember, our Y is our dependent variable, and it depends. It is being driven by the X variable, and that's why the X is also known as the cost driver. It is actually the driver of Y, because its effect will affect the dependent variable. So a good example of a positive correlation can exist on things like maybe fertilizer and harvest. Fertilizer and harvest. You will find a case whereby when we increase the fertilizer, which is actually the input in your farm, you expect the harvest to also increase. So increase in fertilizer results to increase in harvest. Those two variables, remember, our X here will be the fertilizer and our Y here will be the harvest or the output. So this is a very good example of positive, whereby you increase X, which is the amount of fertilizer, the harvest also increases. So they are moving in the same direction. If you try to reduce the amount of fertilizer that you are going to apply, the amount of harvest will also decrease. That is a perfect example of positive correlation. So positive correlation exists where increase in independent variable results to increase in independent variable, the dependent variable, sorry. And decrease in independent variable results to decrease in the dependent variable. So you change this one upward, the other one also changes upward. You change it downward, the other one also changes downward. That is a positive correlation. When we talk about negative, correlation, it is a case whereby when you increase the independent variable, the dependent will go down. Like the example that I gave there of price and quantity demanded. The price and the quantity demanded. Remember here, the price will be our X and the quantity demanded here will be our Y. So in this case, if you increase the price of a commodity, the quantity that the consumers are going to demand is actually going to be low, or is going to be reducing. So you go, or you take this one upwards, then this one goes downward. Then you have a negative kind of correlation. The relationship between these two are said to be negative, where one is increasing, the other one is decreasing. After having said the nature of correlation, then allow me also to mention on the correlation coefficient now. The correlation coefficient. Correlation normally assumes a value of -1, that is the lowest value of correlation that you can ever get. It is from -1 up to +1. So correlation will range from -1 up to +1. Actually here we are talking about correlation. Therefore, if I can put this one maybe in something like a number line, we can have +1 being the highest and -1 being the lowest. In between the two, we have zero correlation. So here we are having from +1 to -1, and we have talked about the nature of correlation, and we have said correlation can either be positive or negative. So correlation can go to positive up to +1, and it can go to negative up to -1. Anytime you are looking or calculating the correlation coefficient, you will find that your answer will always be somewhere in between these two values. You cannot get a correlation that is above 1. You cannot get a correlation that is below -1. Here, between 0 and +1, we have +0.5. And here we have -0.5. That is the value. So this +1, it is actually referred as a perfect positive. Perfect positive, and this -1 is referred as a perfect negative. Perfect positive will result or will arise as a result of this particular scenario. If, for example, I am talking about fertilizer and harvest, if I double the fertilizer, then the harvest should also double. Like for example, if I was applying maybe 10 kg of fertilizer and I was harvesting 3 bags, and then now I increase my fertilizer from 10 to 20, then the harvest also increases from 3 to 6. And then if I double it now again from maybe 20 to 30 kg, that is the fertilizer, then this one will also increase by another three bags. If you have such kind of a scenario whereby you change this one by a certain magnitude, the dependent variable also changes with the same magnitude, you are going to register a perfect positive kind of correlation. Perfect negative correlation will arise whereby I have variables like price and the quantity demanded. If I increase the price by maybe doubling, then the quantity demanded reduces by also a half of what was used to be demanded, then I'm going to be registering kind of a perfect negative. Like for example, if the price was 10 shillings and the quantity that was being demanded was maybe 500 kgs, 10 shillings, 500 kgs was being demanded. I increase this price to 20, then the quantity demanded goes to 250, which is a half of 500. I increase this one to 30, this one goes down by another half of it. You find that I will be registering kind of a perfect negative correlation. Then we have got this region here between +1 and +0.5. This is a region of high. This is a region of high positive. This region from 0 up to 0.5 positive, it is a region of low positive correlation. When we have 0 here, this simply means there is no correlation. This region here, it is low negative. This region here, it is actually high negative, and we go to the perfect like that. So this is actually how we can get the correlation coefficient. Yesterday, I talked about the methods that are used in calculating or determining correlation, whereby I talked about the scatter diagram, the scatter diagram briefly. The scatter diagram, it is actually a pictorial presentation of the way variables are behaving on a graph. You can have some values like maybe x and y. This is x and y variables, and maybe this x is maybe 5, this one is 10, this is maybe 8, this one goes to 15, this one is maybe 10, this one goes to 19, this one maybe it is maybe 13, this one goes to 24. These are x and y's. If you go ahead and you plot this, you present them on a graph paper. Let me just draw my graph paper here, where we have the x-axis and here we have the y-axis. If you go ahead and you plot this, where you have x is 5, y is 10, you will just get 5, and the other one is 10. You mark there where we have 5 and 10, you mark there, that coordinate there. So our coordinate is there. Then where we have 8, it is 15. So we have somewhere there 8, and this one goes to up to 15. You also mark it like that. Where you have 8, you go up, and then you meet with 15 on the y-axis you mark. When you go to 10, maybe we have 10 somewhere there on the graph. This one goes up to 19. So we have maybe 19 there. You mark it like that. So these points having been plotted on a graph like that without drawing a line to join them, it is known as a scatter diagram. So a scatter diagram can also be used to determine the level of correlation, whether it is perfect negative, perfect positive, and high positive, high negative, and all that, by just plotting these points on a curve. And this is normally what happens. The scatter diagram, if you draw your graph and you find that all your points having plotted them, they are appearing on a straight line and sloping positively. Remember, if your line slopes from bottom left to upper right, this is actually positive slope. This is actually a positive slope. So if you find your lines are behaving like this, you plot your points and the points are behaving like this, and they are making a straight line, then that is a perfect positive kind of correlation. If you find that your points are behaving like this, you draw them, they are forming a straight line but sloping like this from top left to bottom right. This is actually a negative correlation, first of all, and because they are making a straight line negatively, it is perfect negative correlation. Then you can have your points behaving like this. They are positively sloping, but like that, almost forming a straight line, but it's not a straight line, but with a positive trend. This one we normally say it is high. It is high positive correlation. If you draw your points and then they behave like this, almost forming a straight line, but not a straight line really, this is actually a high negative. Then you can have your points, they are showing that trend of positivity, but they are far from making a straight line. They are far from making a straight line like that. If they behave like this, they show a positive trend, but they are not near making a straight line. This one we normally say it is actually a low. This is a low positive correlation. Then you can have your points. They are sloping negatively, but very far from making a straight line. Also, we can look and first of all note they are negative, but because they are far from making a straight line, we normally say this is a low negative kind of correlation. Lastly, you can find your points, they are being plotted, but they are behaving something like this. They are forming either a circle or a square. This simply means that there is no correlation at all. So the scatter diagram can give you a rough idea of the level of correlation that exists between variables. And from having noted that, you can be able to decide what to do. Remember, correlation is meant to assist managers or future managers in making decisions. You can be in a managerial position and you want to know what is the correlation between advertising and maybe the demand. Do you intend to increase the demand or reduce, do you intend to increase the advertising expenditure or reduce it or maintain it constant? That one will be determined by the level of correlation. If you find that the more I advertise, the more I get the customers, that is, there is a positive correlation between advertising, then you can increase the expenditure. But if you find it is actually maybe negative, you don't intend or you should not incur additional expenditure in advertising, but rather you should reduce. So it gives you an idea on what to do or the decision that you want to make. If you are that farmer, you can be able to know the correlation between fertilizer and output. The moment you have known the correlation, if it is positive, then you can keep on adding the fertilizer. But remember, you cannot increase the input where and expect maybe the output to increase forever. It will reach a point whereby additional input will actually reduce the output because of what we know about the role of diminishing returns. Therefore, it is actually a very critical topic that can equip the managers on what they should do when being subjected into certain scenarios. So that is actually how we deal with it. So I will stop there for today. When we meet in our next class, we shall move to the next method of calculating correlation, which is actually the correlation coefficient. Thank you very much.